All right, so for this next problem, okay, we want to find the critical numbers and once again, intervals on which the function is increasing, decreasing, and then we want to locate any extreme, okay? So we have a product here, right? So we got to look at this, okay? This is 1/3 power is cube root. Cube root has no restrictions, okay? X has no restrictions, so you can put any X value in here, okay? So the domain is -infinity to +infinity. Okay. Now, what's going to take a while is the derivative of this. Okay. So f prime of x, we got to apply the product rule. Okay. So the derivative of the first part would be 1 times x minus 3 to the 1/3 power. And then plus, okay, and then we have x. And then times, and then we have to bring our power down, so that'd be 1/3. And then times x minus 3. And then we got to subtract 1 from this. So we got to subtract 3/3 from our 1/3 power. So that gives us -2/3. And then times the derivative of the inside here, which would be 1. Okay. All right. So now we should be recognizing that, hey, we have a common factor of x minus 3, and the smallest power is -2/3. So we can factor out an x. Actually, let me clean this up first, and then we'll do that. We still need to do that, so okay. But let me clean this up a little bit. So this f prime of x is equal to x minus 3 to the 1/3 power, and this is plus 1/3 x times x minus 3 to the -2/3 power, okay? So what they have in common is this x minus 3, right? These two terms, this term and this term. And the smallest power is -2/3, so that's the one we can factor out. So f prime of x is equal to x minus 3 to the -2/3 power. And I'm going to put a bracket here. Okay, so we're going to take this one, right? And we're going to subtract what we removed, okay? So that'd be 1/3 minus -2/3. So that would be 1/3 plus 2/3, which would give you 3/3, which is 1. So this is just becomes x minus 3, okay? And then we factored all of this one out, so we're just left with plus 1/3 x. Okay. And then this becomes 1 over x minus 3 to the 2/3 power. This is x minus 3 plus 1/3. Plus 1/3 x, I should say. So this, I'm multiplying with this, right? So this is going to be multiplied with this 1. So this is going to be my numerator, right? So this becomes x minus 3 plus 1/3 x all over x minus 3 to the 2/3 power. Now we have a complex fraction, right? So what I'm going to do is I'm going to multiply by 3 over 3. And we would be left with 3x minus 9 plus x over x minus 3 to the 2/3 power. So then this becomes 4x minus 9 over x minus 3 to the 2/3 power. That's my derivative right there. Sorry. I was petting my dog. All right. I need to show you guys pictures. We bought him he's getting old and he slips on the floor. So we bought him little shoes and he's walking around the house and you hear click, 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 click. He's like a little kid running around. So it cracks me up. All right. So I was petting him. All right. Just a minute ago. All right. So what we have to do here is we got to figure out, all right, where is f prime of x equal to 0? And where is f prime of x? Undefined. Okay, so this is going to be 0 only when the numerator is going to be 0. So that'd be 4x minus 9 equals 0. So that'd be 4x equals 9, or x equals 9/4. Okay, so that's one of our critical values. Okay, when is it? Now, this is why I picked this problem to do with you guys, because this is where we get something that's undefined, right? It's going to be when x, the denominator here, x minus 3 to the 2/3, when that one equals 0, right? So x minus 3 to the 2/3 power is equal to 0. So we would want to raise each side to the reciprocal power. So 0 to the reciprocal power, which would be 3/2, would still give you 0. So this is just x minus 3 equals 0, which would mean x equals 3. So here's our two critical values, right? So we start making our sign chart. We have our intervals. So our domain starts at negative infinity. So we're going to go negative infinity up to the first of these, okay, which would be 9/4 is actually smaller than 3. And then 9/4 to 3. And then 3 to infinity. So there's going to be, since there's only two critical values, there's going to be 2 breaks in our intervals, okay? And then we're going to do test points. And I would do x equals 0. And then here, 9/4. Now let's talk about this, okay? So to pick a number in between here, you got to get a common denominator, okay? So this 3 is the same as 12/4. 12/4 and 3 are the same thing. So we just got to pick a number between 9/4 and 12/4. So let's say 10/4, which is the same as 5/2. And so some people might say, well, Mr. Mitchell, couldn't you use 2.5? Sure, 2.5 is in there, okay? And then for this one, I'd use x equals 4, okay? And then we're going to look at the sign of f prime, okay? So some of these are going to be easy, okay? So this one right here is, if we put 0, x equals 0 in here, this one's going to be 0. And so the whole thing is going to be 0, right? So the sign of hold on a second. Okay, I had to pause the recording because I started to make a mistake. And let me tell you what I just did. Okay, so watch out for this because it's easy to do. I've caught it fairly quickly. I started to put these values into the function. Okay, and I was having, because these have to come out, they can't come out to be 0. And when you put 0 in here, you get 0. Okay, so that, be careful. Don't do that. You got to put this, we're looking at the sign of f prime. We got to put it into this one. Okay. So if we put it into this top right here, okay, that'd be 4 times 0 minus 9. So the top would be negative, okay? And we'd be dividing by 0 minus 3, which is negative, okay? But we're going to square this, so this would be positive, okay? So negative divided by a positive is negative. So on this interval, okay, we would have it would be decreasing, okay, on this interval. And then for 5/2, okay, this top would be 4 times 5/2 would be 20/2, which would be 10 minus 9, that'd be positive. We really don't care about the number value, it's the sign of the number we get, okay? So positive over, and then if we put 5/2 in here, okay, this is going to be, you know what, I'm going to say this, okay, it's not going to matter what this is because we are going to square it and then cube root it, okay? Or cube root it and then square it. Either way, if it's negative, it's going to come out to be positive. So this denominator, I should say this denominator is always going to be positive. So this is positive, okay? And then x equals 4, so 4 times 4 is 16. Okay, that's definitely going to, the top is going to be positive, okay? And then the bottom is 4 minus, that's going to be positive, right? So overall, that's positive divided by positive is going to be positive. So I do the pluses and minuses, and then to tell what the final result is, I write the word neg positive, okay? And then we look at the behavior, right? And so this is behavior of F. This is decreasing, this is increasing, and this is increasing. Okay, so that does not mean, okay, here's a big, and this is another reason why I picked this problem to do. This does not mean it's increasing on 2 intervals. It's actually only increasing on 1 interval because it's increasing the entire time, okay? It's just that the derivative is gonna be undefined at 3, okay? But you're still increasing, okay? All right, so what does that mean? Okay, so this f of x is increasing on the interval, and we would include 9/4, and we wouldn't have a break at 3, we would go all the way to infinity. And then we would say f of x is decreasing on negative infinity to 9/4 with a bracket. Okay? Now, because we're changing from decreasing to increasing, or the derivative is going from negative to positive, remember this is going down and then going up. So right here at 9/4, we have a relative minimum. Okay? All right? So what we have to find f of 9/4. Okay, so I'm going to use my calculator to do that. Okay, so we have 9/4. Since we only have to do it once, I wouldn't type it in. Okay, and then parenthesis, and then 9/4, and then minus 3. I'm putting this into the function, okay, because we're finding a function value here, and then raise that to the 1/3 power. And so I'm going to see if we can, well, I know we're not going to be able to get this. This is -2. I was going to say, if you try to put it into a fraction, like change it to a fraction, it won't because it's a root, okay? So this is -2.044, okay? So what does that tell us? Okay, so we have a f of x has a relative minimum of -2.044 at x equals 9/4 because f prime of x changes from, I started to say positive, negative, sorry, changes from negative to positive at x equals 9/4. Okay, and that's the justification of why there's a relative minimum there. All right, and that's it for today, guys.